Hi there, this is K4A, Knowledge for All educational video channel. We are continuing with learning Scratch, we are continuing with learning Scratch blocks. In this video I'm going to try to explain how and when to use Scratch block, which is named Distance 2. That block is one of the sensing blocks. It's light blue, so if you have opened some other group of blocks, just click on the one circled light blue which says sensing, and then find distance tool. It's fourth from the top, fourth from above, and click and drag it to your right coding window. Okay, let's zoom a little bit to see that better, and let's see what kind of block that is. First of all, we see that this block doesn't have those dents like here, or those pop-ups like here at the bottom, so you cannot attach it to some other blocks. Only way you can put it in some Scratch code is by putting it into some field which is also circle shaped, oval shaped, and that way you can use it. So you cannot use it by attaching it above or at the bottom of the other blocks, but only entering it, putting it into some other block which has oval field for it. Okay, that's the first thing, and the second is that this distance 2 block has a drop down menu which we can click and open and see that we can pick either mouse pointer or some other kind of Scratch sprite which is on the screen or in our Scratch project. On my screen I have buttons, button level 1 and button level 2, so let's try to find it. Yeah, okay, I have selected that one. You can pick whatever you have on your stage. Let's now click on this block before we try to put it in our code, just to see what will happen. Okay, we have some kind of number, and if it's 177. Okay, let's try button level 2, and that's 357. So we can understand how this button, this Scratch block works. And this Scratch blocks works in that way that it gives you distance between the sprite, the object you have this block in, and the one which you choose here. So it's actually distance in pixels between one and two objects, one in which this block is and second which you pick here. Simple as that. Distance is measured in pixels, and distance is measured as the shortest distance between two objects. Distance in real life can be measured in different units like meters. I don't know, American style is feet or inches and so on. So it's like when you try to measure something like some kind of wall or distance between two people and so on. That's how it works in Scratch 2. The only difference is that we have pixels instead of unit instead of meters or inches or so on. Let's now see where and how we can use this block to use it in our games or applications. You can use this block, for example, in some kind of shooting games where you have some kind of turret or enemy, and you want that turret or that enemy to shoot on your player only and only if your player is close enough to that enemy, like that enemy is guarding something, some environment, and your character is approaching to him, then open the fire. So if distance between enemy and the player is lower than, I don't know, 50 pixels or so on, then open fire, then shoot. If not, don't. Simple as that. That's probably the simplest but most effective example I can remember right now. In our game we don't have enemies shooting at our cat, which is good, but the bad thing is that we cannot make them really fast, so we can try this. But we can, for example, maybe use butterfly. I already made some code for it in couple of ways, but I have forgot to turn that into a video. Okay, so let's see. First of all, our butterfly is hidden, so let's show it on our stage and see how that works so far. Okay, so previously we have programmed our butterfly to start from random position. That's here, go to random position, and then forever glides into random position on the screen, so it goes on and on random positions. Let's try to change that with this new block somehow, to make it somehow more natural. Okay, first of all I will detach all this code. I need this size, and instead of go to random position, I will I will try to make it on the same X line as cat, on the same on the same height. Let's see how. Cat is on -40 on Y. Okay, let's type -40 for butterfly too, so they're on the same Y position. That means they're on the same height. Cat is on -40, butterfly is on -40. That's cool. And for X I will leave it at 25. Okay, so let's now go to the motion, and instead of go to random position, I will pick go to XY. We have learned this before, so just click and drag it. And because we have changed here our X and Y position, it's already manifested here on our motion blocks. So we have it here, so let's try it like this. Great. Okay, so now I will try to add this new block distance to into cat, but let's see where. Yeah, I want the cat to tell me how far away she is from the butterfly. Currently, if I press start the game, the green flag, cat says -40, which is Y position, and that's okay. That's what we told her to do, but I don't want that anymore. I want the cat to say distance to, and instead of button, let's say to butterfly to. Okay, let's see. Okay, distance between these two characters, between cat and butterfly, is 153 pixels. So that's cool. Let's see now, is it interactive? If I try to move the cat, will it change? Yes, it changes. It goes lower and lower. So let's see if it can be 0 or close to 0. Yeah. So now both of them are overlapping, and the distance is almost 0. Okay, that's all cool. Let's start it again and stop it, and let's see now how to use this information on butterfly. Okay, first of all, let me see what butterfly does. Butterfly flies Okay, butterfly was flying forever, but he was waiting 1 second and then starting to glide. I don't want that anymore. I want my butterfly. I will now say what I want to do now. I want butterfly to start flying when cat comes too close. Okay. This is the problem I have here. This is my idea and I want to solve it. I want to make it. So I want the butterfly to start flying when cat comes too close. This too close, that means nothing to scratch. That is what we humans use when we talk, and we can understand that more or less good, but Scratch doesn't understand it. Scratch is programming language program, so we have to be more and more precise. So instead of I want butterfly, I want the butterfly to start flying when cat comes too close. Instead of too close, I will have to be more precise and say how many pixels. When cat comes less than 50 pixels close. So currently let me detach it to see how far the cat is. So cat is now 153 pixels far away from the butterfly. That is the distance. Let's see how 50 pixels is close. Okay, maybe 60 would be enough. Okay, 60 pixels. Okay, so I want the butterfly to start flying, which is here, glide. I will copy it just in case if I messed something up here. Okay, so I want butterfly to start flying. That is this one, glide, fly. And next costume is just to make it to look like the wings are flapping. We did that before, so okay, that's flying. But when cat comes less than 50 pixels close. Okay, instead of when, I will type this. I will type if, so that will help you understand what blocks I need here. So I want the butterfly to start flying if cat comes less than 50 pixels close. Okay, so if cat do something, if is one of the control blocks, one of the most important blocks, the question block, and we will drag and drop it to our right window. So if the cat does something, I want butterfly to glide, to fly. Cool, that's maybe I need this wait 1 second too, or maybe not. Okay, we will leave it here. Okay, so if the cat does something, we have butterfly starting flying. Okay, so we need to define this condition here. If the cat comes less than 50 pixels close. Okay, we have seen here that this block distance will help us define distance between cat and butterfly, and because we are coding from butterfly, so we want to know the distance between butterfly and cat. We don't have butterfly here because we are coding in butterfly character. Okay, so distance to cat has to be less than 50 pixels. How to say to Scratch? I need something to measure, to compare. We learned that before. We're using these mathematical operators, and we need this one which says less than. Okay, so if cat is less than 50 pixels, if distance to cat is less than, we said 60, sorry. So this is our condition. If distance to cat, that means distance between cat character and butterfly character, is less than 60, then do something. What something? Glide 1 second and flap your wings. Cool. What else to do here? Don't forget to add forever block. Again, one of the control blocks, orange one, we have learned that before. And why are we adding it here? Well, as before, if I attach this one, this block here, and try to run it, nothing will happen. Even if the cat goes 60 or less. Why is that? Because these blocks were run only once. Scratch was reading them. Okay, I have set size. I have set my position to X and Y. And I have checked that. And that's it. I'm done. I'm finished. If you want this, if you want Scratch to check this on and on, you have to put it in forever block. That's why it's called forever, because it checks on and on forever. So now I hope, oops, it starts right away. No, it doesn't. Okay, because it was some glitch. Okay, because of the previous experiment. Okay, so if I now I'm playing with the cat, and the butterfly should start flying only and only if I come closer than 60 pixels to him. So it's very close. Not yet. So the next step, my next press of the keyboard should trigger the butterfly to start flying. Yeah, it looks good, and it looks more natural, like butterfly is standing here at the beach, and when the cat goes near, butterfly gets afraid and starts fly away. Okay, cool. We have another problem now here, that and that is the butterfly stopped flying around on and on as we had here before. We had it before, like glide forever, wait 1 second, glide, next costume, wait, glide, next costume, wait, glide, next costume, and so on, and that worked fine. But this time we only had it once. Why? Because this condition, if distance to cat, was fulfilled only once. It was, I don't know why it starts always set size. Set distance to cat, distance to cat. Maybe it remembers the last one. Yeah, never mind, we will solve that later. Okay, so for now it works more or less okay. It will start only when I come too close to the cat, only when the cat comes too close to the butterfly, which we wanted, and that is cool. But we made some other problems which we will solve in another video. That's it for this one. Maybe I just have to show you one or two examples more. Yeah, if I click on the stage, then on backdrop, and let me make let me make new backdrop, paint, and I will try to show you what the distance is. Okay, so a little bit too far. Okay, so distance is this. The distance between the cat and the butterfly. That is what we had here in our code. That is this distance to cat field. I have made it into backdrop just to look it simpler and more easier to see what that is. So that is what we were measuring with the distance block. What kind of confusions will you have later, maybe in code, no, stage backdrops? Let's me oops, I have added butterfly too. Nice. Is this eraser? Okay. What kind of problems will you have in your maybe in your work or more complex games? For example, if instead of being here, what if the butterfly was here? So this would be the distance. How the cat is here, C, this is butterfly B, and this is distance D. So some of you will be confused maybe when your other character is not at the same plane, at the same y height. So maybe some of you will be confused when you have some kind of distance here which is not exactly precise in terms of you're not sure how far is it and so on, but it's based on mathematical principles, on Pythagorean theorem, which you probably know from elementary school. If not, check it out. It's very simple. So if you have, for example, like this triangle, and what we had here was that cat and butterfly distance was here A, sometimes will be B, also very simple, but sometimes it will be C. So it won't be just a simple distance between two characters, but it will be calculated as square root on their squares. Okay, I don't want you to confuse you with that anymore, but let me go to maybe again to level just to show you that in example. So for example, if instead I will just copy this first, and what would happen if I, for example, typed here 0 and 0. So you can see now, or maybe even more, maybe. So you can see now how this is the example which I was showing you with Pythagorean theorem. So now the butterfly and the cat are not on the same y position, on the same height. So now the distance is not just simple. In the previous, in this example, you would just subtract two values, one from the butterfly and one from the cat, and in this value, when the y is not the same, you would have to use the square roots and squares to find out how far these objects are one from another. What else can we, another simple, let's see how, where the cat is. The cat is minus 128 and minus 40. So if I type here same values as the cat, you should see them, butterfly and cat, overlapping. Let's see if it works. Yeah. So the distance now says, the cat says the distance now is 0. Why? Because this x and this y value of the butterfly are the same as this x value of the cat and y value of the cat. You can see them overlapping on the screen, and now the distance between them is 0. Let me try to say to make like this b value. Let me try to make that example, and that's it. So cat is on minus 128, y is minus 40, so the x should be same, but the y would be different. Okay, so I just wanted to explain this, and don't worry, that's the end. Why is the distance now? Let's make it 60 to be more simpler to understand. Okay, so why is the distance now between two characters 100, and how did the Scratch measure it? We can see if we compare x and y values of the butterfly with the x and y values of the cat, we can see that the cat is on minus 128x value, and the butterfly is also on minus 128 value. So they are on the same x value. So we won't measure that one, we won't look at that value. Let's see what values differ. The y value differs. Cat is on minus 40 and butterfly is on 60. So their y value, their height is different. Cat is minus 40 and the butterfly is 60. So how that works? Let's go to our backdrop. XY, right? XY grid, yeah. So if you remember this from our coordinate system explanation, y value is this top to bottom axis, blue one, and now the cat is giving us distance between cat and butterfly, comparing those two y values. So cat is here on minus 40 and minus 40, yeah, and butterfly is on 60. So let's try to measure that up. Let's paint another one. So cat is here on minus 40 and this guy here, I'm typing with my mouse, it looks ugly. So this is the distance from minus 40 to 60. So how the Scratch is calculating this d? This is 0. If we go to XY grid, we can see that 0 is here. If we go above, we have into plus numbers. If we go below, we go into negative numbers. So we just have to add these two numbers. From minus 40 to 0, we have 40. We have distance 40. Minus 40 and plus 40 makes it 0. And from 0 to 60, distance is 60. So we just have to sum these two values up. We have to add them, 60 and 40. And if we do that, we get 100. And that is what the Scratch is telling us. 100. That is how it calculated it. So when you have two, what I wanted to show you, when you have two characters which are staying exactly on the same x value or y value, the only thing you have to do, and the Scratch is doing that for you in distance Scratch block, is that it has to add them, and that's how it gets that value. But if you have some more complex, like butterfly is here, then you will get some decimal numbers which are results of this Pythagorean theorem. That's what I wanted to show you. I hope you're not confused very much, but you're getting used to that. Okay, so that's it for this video. Let me just click on this to delete this stage, and delete this ugly stage, and let's go back to our game to see. Yeah, I have messed my butterfly here because I have detached this. Let me just fix that, and that's it for this lesson. Delete this one, attach this one, attach this one, and that's it. When the cat goes closer than 60 pixels, butterfly starts to fly. Cool. That works as we wanted. That's for this video, and the next one we'll try to fix couple of problems which we made by doing this butterfly movement now. Okay, that's it for this video. Thanks for watching, and keep on watching videos and supporting K4A channel. Bye for now.